Hi, everybody. Thank you for joining this month's Cosmic Conversation. Very happy to have you here. Today, we have guest speaker Joe Depasquale. He is a principal science visual developer in the Office of Public Outreach at STScI. His work requires a unique blend of science and art, bringing data from the Hubble and Webb space telescopes to life in colorful views of the cosmos. So prior to joining STScI in 2017, Joe was actually a science imager at NASA's Chandra's X-ray Observatory at the Smithsonian Astrophysical Observatory, where he worked for 16 years following his undergraduate training in astronomy and astrophysics at Villanova. So I will hand it off to Joe. And Joe, thank you for being here, and over off.
Thanks, Jesse, for the introduction. And hi, everyone. Very happy to be here, very excited to be here, sharing this cosmic conversation with you all. And I really do mean a conversation in this sense because I really want to have a conversation with you about data sonification. I'm a part of a team here at Space Telescope that is looking into creating a document of best practices around what it means to sonify data and why we do it. What are the motivations? What do we want people to get from looking at and listening to data sonification? So I do have a few slides that I want to go through, just a quick summary of where we're at so far. And then I have some examples of sonifications that I'd like to share with you all, and then have a discussion about what works, what doesn't work, what you would like to see, where this can go in the future. So I'm going to start with sharing my screen here. Okay. Hopefully you can see my slides. Yeah, okay, getting the thumbs up, great. Okay, so yeah, revealing the universe through sound. And I will admit I'm a little out of my element here because I'm usually a visual person. So, and I am a musician, so sound is important to me. It's near and dear to my heart, but data sonification is a relatively new thing for me. So I'm learning as I go. So yes, our sonification guidelines. Sonification is like the ultimate goal here is like the visuals that we produce for all of our outreach products. It's about communicating complex topics, and in this case, through sound. There are a number of properties to sound that give it you a unique tool set to work with in terms of conveying information. You know, with visuals, it's just what you can take in with your eyes. With sound, you've got pitch, right? Pitch is the frequency of the sound. So human hearing has a broad range of pitches that we can perceive. And that is a useful property for varying pitch in some way, in some meaningful way, to convey information. Volume is another property of sound. Of course, that's the intensity of it, whether it's soft or loud. And as we'll see in a few slides, that's actually something that we would suggest you avoid using as one of your parameters for varying something in a sonification, just because it can be jarring to people for something to quickly go from being soft to loud. Timbre, so that is the quality of the sound, and that would be, say, you know, the difference between a piano playing middle C versus a trumpet or a guitar or a violin. All of these different instruments, they have unique qualities to the sounds they create. So there's a fundamental frequency that is the middle C note, but then there are all these overtones and frequencies that are added on top of that that give it its characteristic sound as that particular instrument. And so timbre is another property that can be used. You can vary timbre in some way to convey information. Position, what we mean here by position is spatial audio. So at the very basic, we would be talking about stereo, right and left, and where something sits in the stereo spectrum. You can, of course, go beyond stereo. There's like quadraphonic, there's like 5.1, 7.1 surround sound, but really most people are going to have a pair of headphones on if they're listening to something, or speakers in front of them. And so stereo is really the way to go. And so you have the opportunity to place things in the stereo space as another property of your data sonification. And then perhaps one of the most important parameters here is time. And specifically, I'm thinking in terms of an image, if you're going to sonify the data from an image is a flat two-dimensional thing that doesn't have a time parameter to it. So time has to be something that is added after the fact if you're going to sonify it. And it's really important to consider how you're adding time into this equation to convey information in a way that makes sense. And we'll get into that in a little bit too. So sonification can support other work or stand alone. I think it's it's best when it can stand alone and when you can think of sound as being the primary or only way that information is communicated. That means that you really have to think about why you're doing it, what you're using to create the sonification, and what you're trying to say with it. Those are all really important things to consider. So if you're taking something that is visually compelling and you're going from that to sonify it, well, why would you do that, right? There are good reasons for doing that. Certainly, NASA has created some sonifications from imagery that is inherently really visually compelling, and they wanted to take it to the next level and create a sonification out of it. And that is useful for inspiring people, for getting people interested in the topics that you're discussing, but it may or may not actually convey useful information. And again, that's something we can get into. As I mentioned earlier with the volume changes can be something that is jarring to a user. So if you have something that goes from a very soft sound to a loud sound, that can be off-putting or disruptive to the experience. And so avoiding that parameter is probably best unless it's absolutely necessary. Another really important thing with sonification is highlighting only one feature at a time. It's possible, we've seen sonifications where there's like a bar sweeping across an image and you're sonifying everything in the image all at once. And unless you've already broken that down and isolated each of those individual components and then displayed or showed the entire sequence, it can be hard for someone coming into it to understand what they're actually hearing and what it means. Again, with the time, this is so important. Time should equal time wherever possible. And that sounds kind of strange, right? But what I mean there is, take, for example, an image of the deep field, like what we've got going on behind me here. This image inherently has time baked into it. When you take a deep field, it's like looking at a core sample of the universe across time. And so they're nearby galaxies, they're brighter, they're bluer. And then as you go deeper into space, further back in time, the galaxies will get redder and redder and change their shape. Their morphologies will change shape. That is a parameter of the image that you can actually use for a sonification. You could take this image, break it down into 3 dimensions, maybe even rotate it slightly, and then have like a plane that sweeps across from the front to the back. And as you encounter different galaxies at different distances, the sounds can change. And so that would be really informative, and it uses time as the parameter that it should be. Representative sound. So this kind of hits home for me because as an image processor for originally the Chandra X-ray Observatory and now with Hubble and Webb, we like to refer to the work that we do as representative color. We take data that is beyond visible light, so beyond information that our eyes can see, and we translate that information into something that we can see. And so these images from the Webb Space Telescope, they're all infrared light, which is light we can't see. But my colleague Elisa Pagan and I, we translate that light into colors and frequencies that our eyes can see so that we can understand better the data that we're getting from the observatory. And so in this sense, we don't have to necessarily maintain the exact wavelength of light that we're seeing, right? What's really important is this representative nature of it. So in terms of infrared light, the longest wavelengths will be colored red, while the shortest wavelengths will be colored blue. We always maintain that. We call that chromatic ordering. We maintain that no matter what wavelengths we're working in. When I worked for Chandra and I made X-ray images, I would take X-ray data and break it down into short, medium, and long wavelength X-rays. So highest to lowest energies, and color those blue to green to red. Similarly with sound, you don't have to, like if you have spectral data of some object, you don't have to map the frequency of that data exactly to a sound that is the same frequency. You can instead use some kind of representative frequency and keep the relative differences the same. Like I've been talking with a colleague about doing a sonification of spectral data where you have 3 peaks in a spectrum, and then there's a change in that data where one of those peaks goes away. And so we were talking about just simply playing like a triad on a piano, 3 notes. That's 3 notes that make up a chord, and then that would represent the first spectrum. And then when one of those peaks goes away, you just take that one middle note away to represent the change in the data. So it doesn't have to map exactly to what the frequencies in the data, but it still gives you some information using representative sound. Okay, so I said it was going to be pretty short for the slides, and that is all I have for slides. So I want to jump into showing some examples and having a discussion about this. And I saw that there was a question, or maybe a question in the chat. Okay, well, that's cool. Awesome.
I've got some questions too. I'm just gonna
Yes.
wait for you, okay?
Okay. Yeah, I mean, if you want to have a discussion right now or jump into examples, I'm open to either.
Let's jump into examples real quick. So I do want everyone to hear what it sounds like, and then we can jump into the discussion.
Okay. So this is part of our documentation here. We've pulled together some examples, some which work better than others, and it's not, there's no value judgment here. This is really about what kind of information is conveyed in each of these sonifications. So, you know, like I said, there's no value judgment. Some work in terms of conveying information better than others, but they're all really interesting, and it's always the ultimate goal is to inspire people, to get people interested in what you're talking about. So this first example here, this comes from a gravitational wave sonification. And in this case, it's a really potent example because if you look at the data, there's a lot of noise in the data, and the actual signal of the gravitational wave is there, but you can't see it visually, but you can clearly hear it. So let me make sure that I'm sharing sound before I start this. Yes, share computer sound. So I'm just going to hit play and hope that you can all hear this, and then we'll talk about it. Okay, it's a very short clip. I assume you all heard it? Okay, and hopefully the sound came through clear enough that you could hear that there was this static noise throughout, right? And then there's this whoop, and that is the signal that we're interested in. There is a little bit of a, this data here is the same kind of data that's been cleaned up so that you can actually visually see the chirp of the two black holes colliding. So it's the same kind of thing. There's a lot of noise, but then there's this chirp. Now it's a little tricky for both of these because they are really just showing like, sorry, they're showing the data, right? So there's not a lot of I guess, you know, slickness to the presentation of this. It really is just like a plot of data, and then you sonify that data. And in this case, I think that the frequencies of sounds that are used are actually like directly mapped from the data. So as we'll see in a lot of these examples, there's a lot of freedom to work with the data that you have. And really, it's about finding what works best to convey the information that you want to convey. So are there any questions at this point?
Yeah, Joe, there's
Yeah.
a quick question in the chat from Carol. Have you heard or seen the planetarium show Audio Universe? And if you have, what are your thoughts?
I actually have not seen that, but it sounds very interesting.
I know that does sound really cool. I'm gonna look that up and see what that is about. Thank you for mentioning it, Carol. Any other open questions for Joe? Feel free to unmute yourself.
Okay, to share. First thing I'm thinking about is Close Encounters of the Third Kind. And I'm balancing these things together. I really didn't realize there was so much science involved. Okay, where do I find all these documents?
Yeah, so we'll share a list of resources after the webinar, Tish. I'll send it via email during the Google group with the sonification. Can I use some of these examples, Joe, to share out? Is that
Oh
okay?
yeah, absolutely. These are all freely available. I can send you this document here that's on the screen.
Excellent. That's awesome.
And
this is a really good example, but is there one that's a whole sonification of a whole image?
Yes, we do have a couple of those. In fact, I think this next one here, user guided. Yeah, this one I really like. It kind of throws things into a different light because now it's user directed. This is an image of the Hubble Deep Field that has been sonified, but you don't actually hear anything until you mouse over it. And of course, I'm not actually hearing anything. But what this is supposed to do is as you move your mouse around the image, you're encountering different galaxies. And this is an example where we're actually using the depth of the image, right? The redshift. So just the most distant galaxies are mapped to really low frequency notes. And as you move, to shorter or closer redshifts, closer galaxies have a higher pitch. I don't know why it's not actually playing the sound. I apologize for that, but you can kind of get the idea that if you're moving around this image, it's user directed. In this case, that time parameter is it's mapped to your experience. You're directing the time of this, right?
Hmm.
It's your interaction with it that determines when something plays.
So you're your own little time lord searching through the image.
Right.
I love this.
Yeah.
This is really interesting that you can travel through time and through sound with the image. And then so you say so as you travel through the image, different frequencies play, is that right? Different sounds?
That's right. It should be playing different frequencies. And again, it's not doing that. Sound will only play on some browsers. Yeah. Okay. Yeah, clearly not this browser.
Clearly not this one.
Yeah.
So, Joe, can you translate the high pitch is close or far away?
I believe in this, the high pitch is closer. Let me see if it
Okay.
works in here. Oh, no, it's not working in Chrome either.
Oh, there you go.
Oh,
Okay. Yeah.
that's cool. Oh, I like this.
Now this requires a lot of work, right? Because you have to go into this image and you have to basically extract every single galaxy from this image and have its redshift known.
Oh, wow.
So that's like a research project in itself.
Yeah,
And
how long would something like this take to make?
yeah, the hardest part is getting the redshifts for all the galaxies in the image. And that's becoming a standard product in Webb images. Like if you take a Webb deep field, one of the products that you can get out of the archive is a database of all of the objects in the image and a rough estimate of their redshift, if it's a deep field. So it's called photometric redshift, right? We're measuring the redshift based on how much of the light shows up in different filters. So it's a very coarse measurement of redshift, but it does give you kind of enough information to do something like this. Let's see, one of these really distant galaxies. There you go. 11.3 billion light years. That's a very low note. That's slightly higher, 11.1 billion light years. Close. How about this star?
Wow.
Oh, that's really high. Yeah, that's in our Milky Way. So that's probably the highest pitch in this whole image.
I like this. This is a way to deeply engage an image, especially thinking of like younger audiences, trying to get them to understand that the smudges are so far away from the bigger stuff in the front.
Right.
When you explain like the really old stars or the red smudges, you can say that and tell them it's very far away, but when it's a static image, they can't see that. So they don't know that it's different than what's in the front. And having the sound and being able to travel through that picture and hear the frequencies of the sound be different, that's a very unique way to engage users in the image and show that time is different. I really think there's something here that could be exciting for programming to dig deeper into images. Yep.
I like the active engagement in that. I think
so interest led.
So much of what we create when it comes to astronomical imagery and sound can be more observer based, and this invites our users to be participants and in the experience, and I really appreciate that.
Exactly, and I agree with you, Amanda. This could be a really great resource for kids. I actually see this being something that like kids can be on teams and they can like try to spot the older, like there's a team of kids that have to spot all the older galaxies. There's a team of kids that have to spot the higher frequencies, and then they have to like talk to each other about why that's different and what sounds they hear. I can see that going a million different ways. So that is very, very cool. Yes.
Yeah. Yeah, I really like this one.
Yeah, that one's great. And I liked what you said before, Joe, about showing how you described it with the sound moving across the image. And I was thinking about those astrovisualizations we do at the Institute that show like fly-throughs of those images.
Yeah.
And it shows like the layers. I could see that with the sound, like having a visualization of that with the sound moving through it like that. I think that could be a really cool visual so that they can see that the static image can now is actually dispersed into all these layers of time. And here is how sound travels through that time and how it's different. That could be really interesting.
Yeah. It really, in that case, I think it would reinforce the visuals, right? You'd have the two parts working together.
Yeah, exactly. Working together instead of working on their own siloed positions. You know what I mean? So this could be really interesting for audiences and audience development when you're thinking about sonification. Have you worked with audiences, like visually impaired audiences, and have you gotten any feedback from them on sonification or successes with sonification? Because I know at STScI, we do have connections with the Federation of the Blind.
That's right.
And I was wondering if there was any input or ways to engage that audience to make sure that this is sort of what they're looking for and needing.
Yes, so we have consulted with last year, we did a press release that was a sonification of some of Webb's first images. And in that case, we worked with colleagues at Chandra, Kim Arkand and her group who sonify images. And they were consulting with a representative from the blind low vision community who provided really valuable feedback to what we were producing and how it could be better, how we could, in this specific case, it was actually one of the suggestions was to break it down because this is one of those things where you've got a lot happening in an image if you sonify the whole thing all at once, right? So the suggestion was to break it down into its components and let the user hear each piece first and then bring it all together in the end. And that was a very useful, I thought, feedback on that one.
No, that is useful.
Yeah.
I like that because it's not then so overwhelming. And then if you hear the different pieces, you can sort of feel how it's working together.
Sorry.
Oh, you're fine.
Yeah. This is actually the one. In this case, this is actually everything all together. So you can get a sense of like how overwhelming it can be to hear it all at once. So we'll just jump through this. And it actually does use spatial audio here as well. For me, it's starting on the right and then going to the left, which is kind of reverse of where it is on the screen, but that is the idea.
Yeah, so you hear every note at once. And I really like the work that Joe, you guys are doing for taking all of that and putting it into step-by-step pieces. And it going back to that image again, that image I'm like obsessed with, the one that you can travel with the sound. I almost view that as like, here, learn all the notes, hear how all the notes sound like, and then that final composition you showed us, this is all the sounds together. But once they're taught the different sounds and can travel through the images and pick up on those different nuances, especially if the sonification matches, throughout the different sound frequencies, they can sort of start to read those full videos, hopefully, or pick up on the little details instead of feeling overwhelmed with everything all at once, because you start off by giving them one sound and one note. You know what I mean? Like you're taking all of the sounds and taking it to the beginning, which is like, here's this sound for this, here's this sound for that, here's how to recognize this. So you're giving them the tools to map out a sonification like that, so it's not too overwhelming.
Yeah. And it actually hits right to the point that was just mentioned in the chat about providing a legend, right? So that you can understand what you're hearing. we usually do provide a legend for this kind of thing. There's a lot of text to read through, of course, but
What is why do you call it a legend? What does that mean?
just like a description of how the sounds are mapped, right? So the stars in this image have a very specific, like, plucky sound.
Yep.
And the gas cloud of the undulating gas cloud of Carina here has its own sort of melodic frequencies that play throughout as you move across it.
Mm-hmm.
So all of that would be written down in the
In the
legend,
legend.
and then you can refer to that as you're listening to it.
Cool.
Yeah.
All right. Well, we're right at the 2:30 mark. So if there are any other further questions, oh, I see here that Karen posted about the legend. So she says, like on a bar graph, the legend says something like orange represents boys and purple represents girls, for example. Oh, I see. Okay, so it's just a little, that makes sense. Thank you,
Yeah.
Karen, for that example. But yeah, if there's any final questions for Joe, anything about sonification, the resources, like I said, I will be sharing the examples out through the email blast. So those folks on live today will get that blast. And if you're part of our email chain, you'll also get it afterwards if you're looking at the recording. So yeah, ask questions, ask them.
Okay, I've got one. We received a couple of Braille books of the solar system from NASA. And wouldn't that be great to have the print, the deep space print behind you with the same thing and some kind of a key, a legend to let us know what I'm feeling and listen to it at the same time, maybe going from left to right or whatever.
Yeah, no, it's interesting that you bring that up because we actually have been working with 3D photo works, like tactile prints. So it's not exactly Braille, but it is like the largest we've done is like a tabletop, right? Where you take an image from wherever. The latest one has been a Webb image where you've converted that into like a topography where brightness matches like a depth, right? So you can feel across the image, and then embedded within this table are these little hot points, which they are audio cues. They'll bring up something about that specific part of the image that plays within the whole unit. And we've got one here at the Institute, and I think it's been on loan a few times to libraries and museums. So it's a great museum piece for an interactive experience of an image in a new way.
Thank you.
Sure.
Or Joe, did you have any specific questions for our group on feedback that you've been looking for? I know this is also a great opportunity for us, NASA's Universal Learning, to hear from our community and what they want to see or hear. Yeah,
I guess my question would be, if you've experienced many of these data sonifications, what has your experience been of interacting with them, or just listening to them? Do you feel like you're getting something new out of it? Do you feel like you're understanding something deeper about the data? Or is it more of like just almost like an entertainment experience where you're just taking something you're already familiar with and seeing it in a new way, hearing it in a new way?
I'd like to mention that at first I thought it was just a beautiful sound, that it really didn't have any meaning, but now I know there's a meaning. So I think the key, or the what we're talking about, putting in what is the meaning of this sound, is really important.
Yeah, exactly. Like knowing how exactly the sounds were mapped and why, that really gives you a deeper understanding of what you're hearing and how it maps to the image itself.
Yeah, I gotta say I agree with that as well, especially thinking of younger audiences or just anyone who just isn't familiar with sonification. And when you're showing something like this, just from my experience of showing sonification, there isn't a lot of like prep that is necessary for the audience. There isn't usually enough time to prep them on what they're about to hear. And I wish that there was. I wish that there was always a little prep to the what and the why before saying, now let's listen to this and tell me what you think. Because most of the time when you ask that, people are like, I don't know, it sounds interesting, but there's nothing beyond the interesting. And like Tish said, she didn't know it had any meaning behind it, right? Like, how do
Right.
we get people to understand that there's meaning behind the sound, that it is representing the data, like visually we're seeing as well. So that piece is going to be crucial, the communication. Yeah.
For me, Joe, the last one you showed, having you give that little brief legend out loud was actually really helpful.
Yes.
Because I think, especially for something people are watching on YouTube or something like that, they're not necessarily going to read the text below, right? They're going to hit play immediately. So if you were to start with a brief legend of, you're about to hear sonification, like an introduction to that sonification with the describing what the pieces might be, I think could be really helpful as a receiver of that information.
Yeah, that's a great idea. So often these are presented as just bam, there it is, listen to it, and there's no prep at all, like you were saying, Jesse. And yeah, having someone like just briefly narrate at the beginning what the sounds mean, that would be so helpful. That's a great idea.
Yeah.
Yeah.
And Karen had a really good comment in the chat. She said, I think our hearing is more sensitive than vision in terms of being able to discriminate. So sometimes you can hear something that's harder to see, so you can get extra info out of the visual image that you wouldn't otherwise get. And that is such a good point that I didn't even think about. But yeah, you can get the different nuances of sound that you just can't always see visually. So that could be really cool. It's like, here's the visual. Now let's go deeper with sound. What are some things you notice with the sound that you just can't get with the visual, and how is that different and, similarly? So that's cool.
Yeah, the gravitational wave is a good example of that.
Yeah. All right. Well, we are 6 minutes past, so I do feel bad keeping everyone here. But thank you so much for this conversation. This was really interesting. Thank you again, Joe, for showing us about sonification and also showing us the steps of sonification and the different sounds and the different examples you gave. I'm really excited to hear and see maybe in a next iteration of Cosmic Conversations next year what sonification is up to at STScI. So hopefully we'll bring you back and we'll have some fun updates. But thank you all today. Feel free to drop out now and we'll catch you all for next month, which is on accessibility.